So today we're going to work on chapter 4.4. Okay, chapter 4.4. And what we're going to talk about today is something called linear functions. Linear functions. Oh, yeah. Linear functions. Linear functions. Anyone have any idea? What do you think a linear function is? What does the word linear probably mean?
Has the word line in it.
Has the word line in it. Okay, so we're going to be drawing lines. Okay, a linear function is when a line fits the data. Okay, so a linear function is when a line can represent a real world situation. Okay, when a line can represent a real world situation. And this is the kind of math that we kind of like to do because we want you to be able to, find something that actually makes sense. So you're not just learning math, but you're learning something that you can actually use in the real world. Okay, so for example number 1, I tell you, during Black Friday, which was last week, okay, did any of you guys go do any Black Friday shopping? Some of you, did any of you actually get up at I don't even know what time stores open, 5 a.m.?
They open on Thursday night.
Oh, now they open on Thursday night. But some of you people went out and hopefully no one stepped on you or anything.
I went in Hawaii and it was I went 2 hours ahead.
That sounds rough. Real rough. Okay, during Black Friday, a store is selling DVDs. Store is selling DVDs for $3. I know they're pretty cheap. And CDs for $1. During Black Friday, a store is selling DVDs for $3. And does anyone have? It doesn't look like it. Sorry, I know it's crazy. DVDs for $3 and CDs for $1. Okay, graph the equation. Graph the equation. Y equals 6 minus 3x to find all possible values of DVDs and CDs you can buy with $6. Okay, so a store is selling DVDs for $3 and CDs for $1. And we want to figure out, if I have $6, how many could I buy? Okay, so this is something where there's going to be a lot of different combinations, right? And we don't really want to sit there and try to figure out okay, well, I could buy, 1 CD and then how many DVDs could I buy? This is something where a graph actually shows you all that. So you don't have to do all of the add, subtract, multiply, divide, that kind of math. Because you can actually graph this and it'll tell you, okay, how many you can buy. So here, we're going to make a graph. Now, if we're talking about money, okay, which part of the graph do you think we need? Do we need all 4 of the corners? Which corner do we need? Darian just said it. Just the positive ones, right? Okay, you can't have negative money. Okay, we're not talking about credit cards here. Okay, because that's negative money, in case anyone didn't know. Okay, you do have to pay it. Usually have to pay more than that. Okay. So we're going to draw just the positive part of the graph. Okay, this is always your x, and this is always your y. Okay, so here, if I want to graph this, okay, how do I graph y equals 6 minus 3x? From our last unit, what do we know about graphing? What form does our line have to be written in? Slope-intercept form, but what does it look like? What does slope-intercept form look like? Y equals what? Y equals mx plus b. Is this written in y equals mx plus b form? No, it's kind of backwards. Okay, the part that's attached to the x needs to be first. So we know that the y is already there. How can I write this so that the x part is first? You just write negative 3x, and then what's the sign on the 6? Is it plus or minus? Plus, right? So we can literally just rearrange that. Okay, you just rearrange it so that the x part is first, and make sure you take the sign of whatever's attached to it. Then I actually got to graph. So where do I make my first point?
6.
At 6. Okay, and what's that called usually? Nope, that's called the beginning point, which is the y-intercept. Okay, this is the y-intercept. And that tells you where to begin. So we're going to make our first point on the y-axis, so it's always on the up and down line at 6. Then how do I move? I know this is my slope. So slope tells you negative 3. What do I have to do to tell me how to move? I have to make that into a what? A fraction. How do I write negative 3 as fraction? Just put over 1. Okay, that's all we have to do is just put negative 3 over 1. So that tells me what? What does that tell me? Go down 3 and over 1. And we're always moving to the right, so down 1, 2, 3 over 1. Then if I want to make another point, where would I make my next one? Down 3 and over 1 again. Now I'm back to 0. Okay, so this tells me, what is this telling me? What point is this right here? What point? If I wanted to label that point, what point would you call that? 0, 6. What point is this right here? Over 1, up 3. And this one is what? Over how many? Over 2, up 0. This is 2, 0. So what is this basically telling me? Does anyone know? Does anyone know, what is this telling me? Because we're asking, we want to know how many combinations of DVDs and CDs you can buy with $6. This is actually telling you the combinations. 0, 6 would be what? 0 what?
0 DVDs.
And 6 CDs, exactly. Okay, so we could buy 0 DVD and 6 CDs. I'm not going to put the S because I feel like it looks funny. Okay, how about 1, 3? What is that telling you? How many DVDs? 1 DVD and 3 CDs. Or my last combination would be what? 2 DVDs and 0 CDs. Okay, so that's actually telling you a combination of things. Okay, and you can find that just by looking at a graph. Okay, so we're going to do a couple more, so don't worry about it too much. Okay, we are going to do a couple more. Okay, next thing I'd like you, excuse me, to do for example number 2, yes, for example number 2, I would like you to graph y equals x plus 2. Y equals x plus 2. Graph y equals x plus 2. Now, usually, okay, and in your book, I'm going to show you guys this example. Okay, you don't have to write this down. But in your book, they have you do all of this. Okay? They have you find, like, you plug in points and then solve for them and then graph them. Do we really need to plug in points to be able to graph something? No. Why? Because you know slope-intercept form, right? I feel like your book is doing this backwards. Okay, when I taught you guys how to do slope-intercept form and figure out where to begin and how to move, we skipped the part about just plotting things, like just putting dots and connecting them. Because once you know slope-intercept form, you don't need to know how to just connect the dots. Okay? So this one, even though in your book it's asking you to make a table of values, you don't have to do that for me. Okay? I just want you to graph them. Okay? So if I just wanted you to graph this is just a real basic graph. Okay? Where do I first start? Where is my beginning point? At 2, and is it 2 up and down or 2 left to, 2 on the up and down axis or 2 on the side to side axis? 2 on the up and down, so that's, what's this called? This is the y-intercept. Okay, so it crosses the y, it intercepts the y-axis at 2. Then your slope tells you what? Slope tells us how to move, and how am I going to move? What's the number? What's the coefficient attached to x there? 1. But remember, I need to make it a fraction, so 1 over what? 1. So that tells you what? Move up 1 and right 1. Up 1, over 1. Now, if I wanted you to find the points on here, could you label these points? Yeah. Could you get to another one and label another point? Yeah. So I don't think you need to make that table of values and plug things in. Okay? You can just read the points right off of a graph. Okay? So once you have at least 2 points, you connect the dot. Okay? So part of your homework is just going to be remembering how to graph. Okay? Just remembering how to graph. Okay? Next one I want to go over is, I just lost my place. Where did I go? Sorry. Okay, so if I give you, and I'm going to switch the pages because this one's going to be a little bit longer, and I think this might be our last one. Okay, for number 3. Okay, for number 3, if I tell you a store sells assorted nuts. Store sells assorted nuts. Does anyone know what assorted nuts are? It's like, if any of you guys ever been to, it's called Sierra Nut House, I think. Has anyone ever been to Simonian Farms?
Yeah.
Okay, you know where you like go and get pumpkins and stuff? Well, I take my family to go and get pumpkins and stuff. I don't know what else they have there. Okay, this is like people that, you know, roast their own Christmas treat things, and you can basically like buy things by the pound. Okay, so a store sells assorted nuts for $5.95 per pound. For $5.95 per pound. Okay, a store sells assorted nuts for $5.95 per pound. It's, you know what, it sounds really expensive, but if you go to the store and buy like something really little, like, do any of you, if you guys have seen those, like the little cans of Planters nuts, okay, those things are usually how much? Like $4 each, something like that? Do you think you're really getting a pound in there? No. So this really isn't that expensive. I know that a lot of you don't really think about using math in your everyday life, but especially when you go to the grocery store and you're trying to figure out, like, okay, is it better to buy, like, you know.
She's a math genius.
She's a math genius. It's just multiplication. You could do it with a calculator if you need to.
She doesn't use her calculator.
Well, then she's just good at multiplication. That's all good. Okay, so $5.95. I would like you to, the A portion, I would like you to write a function. Write a function to represent. Write a function to represent the total cost. The total cost of any number of pounds. Number of pounds you buy. Okay, so we're going to start with write a function to represent the total cost of any number of pounds that you buy. So basically what we're trying to do is we're trying to write a y equals mx plus b equation. Okay, a y equals mx plus b. Okay, we want to write that equation. The b part is always any initial cost. Okay, in here we know that that's the y-intercept, but this is any initial cost. Okay, any initial cost. The m part is always the per cost. Okay, so it's always the per cost. So sometimes it's like miles per gallon, or it could be $5.95 per pound. Okay, so here, what is your y going to equal? Which one is the dependent variable and which is the independent variable? Is the cost going to depend or the amount that you buy? I take that back. When we're thinking about independent and dependent, independent is the one that you control. Are you in control of the cost or how much you buy? How much you buy, okay? The x part is always what you are in control of. What you are in control of. Okay? That is the independent variable. So the independent variable is what you are in control of. Okay? The dependent variable is what you're not in control of. So I'm not going to write what you're not in control of, because if one is what you are in control of, the other one is just the other one. Okay, so here, if I want to write an equation here, okay, and remember, I'm trying to figure out cost of the number of pounds. So which variables, what letters do you think I should be using here? What should I use for cost? C? Okay. What should I use for number of pounds? P? Okay, let's do P. So here, is the cost the dependent or the independent variable? What are you in control of? The cost or the number of pounds? The number of pounds. So we're going to put the P right here. So we're always writing our y equals mx plus b. Okay, so the P is going to go in the independent variable cost, independent variable space. So if this one is what you're in control of, what are you not in control of? The C for cost. Now you just have to fill it in. Okay, what did we tell you about the price? The cost is what? $5.95 per pound. So where should the $5.95 go? For M or for B? M. So $5.95 per pound. Now, is there any initial cost here? Like, is there a charge to like walk in the store? No. Okay. This is your function. Okay. A, that is your answer. Okay. That is the answer that I'm looking for A. We are just writing an equation. Okay. That is how you write the equation. Once you get used to these, they'll probably be pretty easy. It's just figuring out where the different parts go. That's kind of the difficult part. Okay. The B portion that I would like you to complete is I want you to complete a function table. Complete a function table to find the cost of 1, 2, 3, 4, or 5 pounds of nuts. So complete a function table. So this is kind of what we worked on yesterday. Okay, remember the function table? Yes, ma'am.
When you say or 5 pounds, does that mean and?
I meant of. Sorry. Complete a function table to find the cost of. That's an F.
No, the 1, 2, 3, 4, 5.
Oh, we're going to do all of them, yeah. So, yes, if we mean and, but you're not buying 1 and 2 and 3 and 4. So, you are a good English person. You're thinking English ways, not math ways, okay? So we're gonna write the function table. So usually we write, I said that XY table, okay? So you're always gonna write your X, then your equation, or your formula, and then the Y. Here, which is in the X part? The P or the C? Which one's in the X spot? The P. So number of pounds. What's the equation that we're plugging into? 595 times P. And your Y is your cost. Okay, the Y is your cost. Okay, now let's actually just plug things in. So what am I going to plug in for the different number of pounds I want to find? 1, 2, 3, 4, and 5. Then this one is just the formula. Okay, so really you're doing 595 times 1, and what would your cost be? 595. Okay, then this one you do 595 times 2. Okay, if you work that out, you get 1190. If we get 595 times 3, that would give you a total cost of 1785. Then plug in 595 times 4. That gives you a cost of 2380. And finally, on number 5, or 5, if you multiply 595 times 5, you get a total cost of 2975. Okay, obviously you guys would have to work that out, okay, but you could do the multiplication. Then, it's also going to ask you to graph, okay? You will have graphs on your homework, okay? So don't worry about it. Your graphs are already going to be there, or your grids will be on there, okay? So your graphs are going to be on there, okay? This one, if we made a graph, do you think that this is going to be a straight line graph, or is it going to be like super funky looking? Do you think that it's going to be a straight line? Is the cost continuous? Would this show a linear relationship? No? Do you think that it's a linear relationship? Because we're running out of time, I'm not going to make you guys graph this, but I'm going to show you what would happen if you did graph it. Okay, it looks just like this. What does that tell you? Is this a linear relationship? Okay, so the question is going to ask you, is the function continuous or discrete? Okay, continuous means, is it a straight line? It is continuous. Where are you guys going? You still have like 7 minutes, okay? Discrete means it's like jumping all over the place, okay? You guys are working on, for homework tonight, you are working on page 301. I would like you to do numbers 1 through 7. Okay, page 301, numbers 1 through 7. Do your best to get through these. Okay, if you don't get all the way through them, we will work them out. I will help you guys on block day, but do your best to try to get through these.